Hey class, today we're going to be talking about parallel lines and transversals. We're going to be using these four examples to help us get an understanding of how to find the missing variable with parallel lines and transversals. So looking at the first example. In this example it says, in the figure shown, line Q and R are parallel. It says if the measure of angle 2 is 62 degrees, what is the measure of angle 5? Okay, so in order for us to solve this problem, we're going to use these couple steps that we have off to the left side of the screen, along with that hint that's at the bottom. The first thing we got to do is understand what the question is asking us to solve for. In this question, they're asking us to find what is the measure of angle 5. Alright, so we're going to use angle relationships to help us along the way in solving this problem. So you came across a lot of these angle relationships when you did your definitions. Okay, so we're going to use those angle relationships to help us fill in the missing angles, and then in some cases we have to set up the equation and solve. Now the hint that was given is that all straight lines are equal to 180 degrees, and the reason why we have straight lines are equal to 180 degrees is kind of like a half moon. Okay, it's kind of cut in half. So we're filling in based off the information. We're going to be giving half or a portion of the actual line, and we have to use that to find the missing portion, which is an angle. Okay, now the portion in this problem that they gave us was the measure of angle 2, and they told us that the measure of angle 2 was 62 degrees. So that portion we know. What we can find is the other portion, which is this one. Okay, the way we can find that portion is by taking what we know, which is every straight line is 180 degrees, and subtracting 62 from it. So when we do that, we get 118. Okay, so the other portion that was missing is 118 degrees. Now using the angle relationships, what we can find out is that every four angles actually make a full circle. We found what was half of the circle, so that means the other half is going to be very similar, but the placement of those degrees are important. So like if I know here, we found out that was 118. If we look at it real close, we actually can make another half moon here. But if that portion is 118, and we come here, the other portion has to be 62. And it goes the same thing with the other side. If I know that this is 62, and I can actually still make another half moon, now you know it ain't a perfect circle. If it's 62 there, that means this portion that we just found is going to be 118. Okay? And now that was just that line for line Q. But the question that they're asking us to find in this problem, they want us to find the measure of angle 5. So we only know all the measurements for line Q. So we got to find the measurements for line R, because the measure of angle 5 is on line R. But now we can use the measurements that we had or have for line Q to get to the measurements or get to the angle measures on that line for R. What we can do is we have to know that one of the actual relationships that you took down was same side interior angles. Same side interior angles are supplementary. Supplementary, which means 180 degrees. Supplementary or same side interior angles are inside your parallel lines on the same side of my transversal. Okay, the transversal is the line that cuts the two parallel lines. So if you notice that 5 is on this side, but also 62 is right here as well. Those two, angle 5 and 62 degrees, are on the same side of the transversal inside my parallel lines. So those are considered to be same side interior angles. And they're supplementary, which is 180 degrees. Okay? So that means if I know angle 3 is 62 degrees, that means the rest of that 180 has to be 118. So that means the measure of angle 5 is going to be 118 degrees. Okay? So my answer to that question will be 118 degrees. That will be my answer. Alright, so let's move to our next one. Alright, so our second example. It says, in the figure below, line Y is parallel to line Z. If the measure of angle 2 measures 147 degrees, what is the measure of angle 8? So using what we know that every straight line makes 180 degrees. And with every straight line, we can use that 180 to find out what is missing. Okay? So let's go ahead and label the measure of angle 2. Measure of angle 2 is here, and with that angle 2 there, that's going to be 147. What we want to find in our final, we're looking for the measure of angle 8, which is down here in the corner. Okay, but before we do that, we need to start filling in everything on line Z. So if we go with half, they gave us some of the half of the circle, so we got to find the rest. So we're going to take 180 and minus 147. That's going to give me 33. So the missing portion of that half a circle for angle 1 and 2 is 33. 33. Okay? So let's use it. So if this is 33 and I go right next to it, which is still on a straight line, so 1 and 3 makes a straight line also. So if this is 33, that means the measure of angle 3 is 147. And if that's 147 and I go to angle 4, that has to be 33. So we're really just alternating the angle measures based off what they gave us, okay, and what we did after we subtracted and what we got, okay. But now we got to use what we just did to get to line Y, where those other angles are. Same concept. Same side interior angles. If they're same side interior angles, they're 180 degrees. If we look at the measure of angle 4, which is 33, what is on the same side as angle 4? Angle 6. So if they're on the same side of my transversal inside my parallel lines, they're equal to 180 degrees. So that means if angle 4 is 33, that means angle 6 has to be the remainder of that 180, which is 147. Okay, so that's still not the answer that we're looking for. We're looking for the measure of 8. So if 147 is here, but ain't 8 right beside it? So since 8 is right beside it, that means the measure of angle 8 has to be 33 degrees. So the answer to that problem is 33 degrees. Alright, so now we're going to move on to our next example. It says, in the figure, line M is parallel to line N. What is the measure of the angle X? The question is asking me to find the measure of X. So I'm going to go ahead and just kind of highlight it, put my little angle thing there. Okay, so in this problem, they gave me 123, and 123 is down here. Okay, so I can go ahead and start and fill in like my half, just to find the portion that I'm missing. So that means I'm going to take 180 and minus 123. That's going to give me 57. So that portion that was missing on that straight line for N is 57. Now I can use those 2 degree measures to fill in the rest. So if 57 is here, right beside it has to be 123. Okay, if 123 is here, then if I go right beside it, it has to be 57. So that's filled in. But now I have to use what I know to get to the other line, which is M. Same side interior angles. If 57 is there, I can find the one right here because 2 angles side by side equals 180 degrees. So if those 2 angles equal 180 degrees, that means 57 is in this corner. That means 123 has to be in that corner. And now that I know that 123 is here, I can find out what's right beside it, because any 2 angles side by side is equal to 180 degrees. So that means the measure of X is going to be 57 degrees. and that will be the answer for that one. Alright, so now let's look at our last example. And in this last example, this is a little bit more complex, but we have to combine some of the things that we've learned already, like triangles, okay, and then also using our angle relationships, and it's going to be, which will make it easier to solve. Okay, so in knowing what we know, every straight line is equal to 180 degrees, and we have to find the measure of z in this one. Okay, that's what the question is asking, and it told us in the beginning what two lines were parallel. Line F and G are parallel, and they're cut by the two transversals, and we're looking, and what we're about to do is find the measure of z. Now, in order to solve this one, my focus is going to be on this triangle that was formed in the middle, and we know that every triangle is also equal to 180 degrees. Okay, so because these measures are on the outside, I can use these measures on the outside to find the angle measures that are be on the inside of my triangle by taking each one and subtracting it from 180. So I'm going to do this side by subtracting 180. So the angle right beside it, this angle here, is going to be 44. Then I go to my other side and take that and subtract it also from 180. And that's going to give me 30. So that means the angle that's on the side of that, this piece here, is going to be 30 degrees. Okay, so now we got the two angles on the inside of the triangle. Now we can find the third angle at the top just by using what we know. We know all three angles in the triangle add up to be 180 degrees. So therefore we can take 44 and add it to 30. That's going to give me 74. Then 74 is then going to be again subtracted from 180. That'll be 106. So that top angle is 106 degrees. Okay, now using your angle relationships, we can find out what the measure of angle z is by using 106. So in your angle relationships, you took a definition called vertical angles, and vertical angles basically states that the angles that are across from each other, basically crossing the intersection of any two lines, they're going to form congruent angles, and congruent means they are the same. So because they are congruent, I can take this and go here. That means the measure of angle z is going to be equal to 106. Okay, so what we just did in these examples, we just learned how to solve parallel lines and transversals using our angle relationships and setting up equations by knowing that straight lines are 180 degrees and that triangles are also 180 degrees. So the things that we learned previously before this lesson is going to help us solve these problems as they become more difficult. Okay, so parallel lines and transversals, just to recap, always remember every straight line is equal to 180 degrees, but always read the question first to understand what they're looking for, and that's how we do, or how we solve parallel lines and transversals.